How's it going, everybody? I want to talk a little bit about different calibers and energy of different calibers, namely 380, 9mm, 45 ACP, and 10mm. I am a loader, a reloader. I have got, a few different reloading manuals here. Sorry about the ratchet of the tripod here. I actually came down here. I was going to do a little side-by-side of the car P380 and my car CW9, and I'll still probably throw that in a little bit. But I got to thinking about the power factors between a 380 and a 9mm and a 38 special. Oh yeah, I have that too, 38 special, so on and so forth. Well, I dug out my books and I started looking through them. And most people know that bullet power, let's say, is measured in how fast the bullet's traveling, the bullet weight, and between those two factors, the weight and size of the bullet and the speed in which it's traveling, calculates the energy of that bullet. Now, the energy of the bullet is quote-unquote the knockdown power. Okay, you hear all the guys, the big 45 guys and stuff, talk about the knockdown power and stuff of a 45, so on and so forth. And it does have, a lot of knockdown power. It's got a 230 grain chunk of lead flying out there. But that isn't everything. I went through and I pulled up some numbers. I mainly wanted to compare the 380 and the 9mm, and I went there and then I was like, I hear a lot of people talking about the 38 special, that it's about like a 380 or a 9mm, and I couldn't remember which, and I went and got some info on that, and then I was like, well, I'm going to check out the 45, and then I went to the 10mm and all that kind of crap. I just want to show you real quick here. I pulled out my damn bookmarks, which I shouldn't have done. But, for instance, 38 special. If you look at this will show you a Nosler 158 grain hollow point. Okay, it gives you the ballistic coefficient. The higher that ballistic coefficient number, the more density, the more mass the bullet has. Different brands of powder. You have your max powder charges, like right here with AA number 2, your max charge on 158 grain 38 special would be 4 grains of powder that will spit the bullet out at 760 feet per second. Okay, now you can see here's one up here at 830. So there's a difference in what powder that you use. Okay, you see that's 4.1 grains, 830 feet per second. AA number 2, 4 grains, only putting it out at 760 feet per second. Now this stuff is measured, and it will show you back here what type of gun they fired to do the testing. Okay, right there. What am I in? Okay, they're calling it a rifle, but this is going to be higher than most people's ballistics, but it gives you a baseline. See, this is showing a 7.75 inch barrel. Okay, they show you the case. It's a Federal case. The primer is a Winchester WSP, so on and so forth. But you can take that velocity that the chart shows you. You have this in all different weights. They show it for 125 grain for 38 special. They show it for 150 and 158 grain. Okay, So what you do is you take this right here, 38 special. You're looking at 158 grain. And just for giggles, let's use this most powerful one, 830 feet per second. You go back here to the back of the book, and you find there's 10 millimeter, went too far, 38, and there's 38 caliber, 125 grain. What the hell did we just look at? I'm thinking it was the what a retard. Was that the 158 grain? Or 150 grain? I'm thinking it was the 158, but I can't remember now. Okay, you'll come over here, and this chart goes off of velocity. So the first one is 2,300 feet per second, 22, 21, 2,000, and it keeps going down. And you go down to where, shit, it's at the very bottom here. There's 800. Okay? So at 800 feet per second, 158 grain, at the muzzle, 224 foot-pounds of energy. Okay? As you can see, as you go up in velocity, the energy goes up. If that thing was traveling at 1,400 feet per second, it'd have 688 foot-pounds of energy. As the bullet slows, so does the energy lower. Okay, so this is just a, just a little representation. There's many different manufacturers of ammo out there. I mean, these numbers will vary greatly. But I went off of bullet weights, max charges, and just went off to the chart. You don't need to see that. Okay, first off, on the 9mm and the 380, seeing as how they're both the same bullet, they're both a .355 diameter bullet, I compared the two at the same bullet weight. So that's 115 grain full metal jacket. The energy at the muzzle with the 9mm was 309 thereabouts. Okay, it's just a hair higher than that because I think the velocity was like 6 or 7 over the even number. I think that the 9mm was like 1,106 feet per second, let's say. Okay, so this 309 is at 1,100. Okay, but it isn't going to be up from that very much, if even a full point. So 9mm was 309 foot-pounds of energy. The 380, same size bullet, 163 foot-pounds of energy. Now I looked up, typically you don't get a 115 grain bullet in a 380. You usually get a 95 grain, 90 grain. Well, the energy on the 90 grain went from 163 to 200 foot-pounds of energy. And it's just a relationship because the bullet was traveling a fair amount faster. Lighter bullet, greater speed, made the energy go up. Okay, so like I say, this can vary quite a bit. They both were 115 grain. 38 special, 125 grain, 275 foot-pounds of energy. Okay, so that's down from the 9mm right there. Here again, 115 grain with the 9mm, 125 grain with the 38 special. But here again, this is the highest load in the book, in the Nosler book. Okay, 45 ACP, 230 grain, 327 foot-pounds of energy. That kind of surprised me. Caveat to this, I know, like if you go onto Buffalo Bore's website, I mean they load some pretty hot stuff, and I know I've seen some 45 ACP plus P or whatever they call it, that's just under 600 foot-pounds of energy, 570 something I think. So I mean that's up a whole bunch from 230 foot-pounds of energy on this particular load. Now these load manuals here, they're very conservative. Okay, They can't have a liability of putting this stuff in here, you know, really, really hot, taking a chance on somebody getting hurt or blowing up their gun. So they're pretty conservative numbers. 10 millimeter, 180 grain, full metal jacket. See, the 45 was spitting that bullet out, 230 grain bullet at like 800 feet per second. You know, that, I mean, that's slow. 800 feet per second with the 45 grain bullet, that's what gave it the 327 foot-pounds of energy. The 10 millimeter, 180 grain, which is very common for the 10 mil, spitting the bullet out at about 1200 feet per second. So you're 400 feet per second faster than the 45, and that's putting the energy at 575 foot-pounds of energy. Now I can tell you that I know that 10 millimeter hits harder than a 45 does. Me and a buddy of mine went to a shooting range up north of town, an actual range. He belongs to this range, and they have these 1-inch thick steel silhouettes that whenever you hit them, they're supposed to fall over. Well, we were both shooting. I didn't have a 45 at the time. I had my 10 millimeter, and he had a Springfield XD 45. And there's this one target that was tough to knock over, and he kept hitting that thing with his 45 and he couldn't knock it over. I hit it with my 10 millimeter and knocked it over. We reset it. We did it 3 times, and we weren't super close. I mean, I don't remember what we were back. I would guess 20-25 yards or something like that. But he'd hit it with his 45 and it would not knock it over. I'd hit it with the 10 millimeter and it'd knock it over. So the proof's in the pudding, you know. But anyway, just kind of a gee whiz on some ballistic information between, you know, some pretty popular calibers. You know, you can go on and look. I mean, Buffalo Bore even makes a pretty hot 380 load, you know, that I know would be quite a bit higher than these numbers I'm getting out of that Nosler book. So that's where we are. Man, already 12 minutes. Jeez. Alright, real quick. Boy, I don't even know if I want to. You know what? I'm just going to leave it there. I'm just going to leave it there and just do this video as just, you know, ballistics this or that. I'm not going to go into comparing these and, you know, putting it next to the Glock and stuff. But I will show you. Well, you know what? This is relevant. Whoa, did y'all see where that one went? I didn't. We will put a visual on the difference between a 380 and a 9 millimeter bullet. Do I dare? I'm gonna crank you all down. I'm gonna tilt you up, and I'm gonna crank you down. Okay. Now you can see the difference in size. Now that bullet, now the actual size difference of these two isn't that great. If you take a good look at the length of the cases. Okay. You see on the case, dang, burn it. That 380 case is not much shorter at all than that 9 mil. Now this is a Hornady XTP. I mean, the bullet is, you know, sticking out of it further. It's a different shape. It's not just a, you know, plain old son of a gun. But the case length, I think it's like 2 millimeters difference, if I'm not mistaken. You know, and that's where your powder and stuff goes. Let me see if I can see the... On this, the bullet is seated. Damn, I need a pointer. Yeah. it looks like that the bullet on both of these is seated about the same depth. Oops. Right there. So that's bullet down to right there and up and out. Okay, the powder is right down in here. This one's not so easy to see. Right there is the bullet depth on this, on the 380. So this right here is all just bullet. Right down in here is where the powder is. You know. So you look at the depth of how deep the bullet is seated in there. Boy, I wish you could tell more about that. But looking at this right here, I mean, the bullet depth, the distance it's seated down there appears to me to be about the same as the case height. It looks like the 9mm is seated about 2 millimeters higher in the case than the 380. You know, so there really isn't that much difference in powder. I mean, there is some difference. You know, 2 millimeters, whenever you're talking about powder charges, can be quite a bit. But anyway, that's some gee whiz on all this stuff. Hopefully it was informative. Oh hell, I'll do a video on the two cars at another time. So thanks for watching, you guys. You all take care. Have a great evening. I appreciate all the new subs. Keep doing what you're doing. We'll see you later.